Welcome to EDU World Space.
What is known from this problem is that the resistance is 10 kiloohms, which is 10 times 10 to the 3 ohms, and the terminal voltage is 14 kilovolts, which is 14 times 10 to the 3 volts. And in part A, you're given an internal resistance of 2000 ohms, which is 2 times 10 to the 3 ohms, and you're asked to find the current. So we'll use this equation here that VAB is equal to the the EMF. Sorry, and we're actually given the EMF here minus the current times the internal resistance, and we also know that VAB is equal to I times R. So if we substitute that into here, then we find that IR is equal to E minus IR. Or if we rearrange and solve for I, then we have I is equal to E over R plus R. And these are numbers that we have here. So we have 14 times 10 to the 3 volts over 2 times 10 to the 3 ohms plus 10 times 10 to the 3 ohms. And this gives a current of 1.17 amperes. Now in part B, we're asked to find what power is dissipated by this resistor, and in this case, it's a person's body. So we use the equation that power is equal to I squared R, and we just found that the current is 1.17 amperes, and then we just plug in for that, and then the resistance after which we find that the power is 1.37 times 10 to the 4 watts. Okay, and there is a part C. So let's get our next page. In part C of this problem, where the question reads, if the power supply is to be made safe by increasing the internal resistance, what should the internal resistance be for the maximum current in the situation above to be 1 ampere or less? So let's take the current to be 1 milliampere, as it says in the question, 1 milliampere. And then we have to find the internal resistance. So we'll use the equation that we had before, which is E equal to I R plus R. And then we can solve for the internal resistance, which tells us that the internal resistance is E minus IR over I. And after we plug in the numbers, so we have 14 times 10 to the 3 volts minus And now we have 1 milliampere, so 1 times 10 to the minus 3 amperes. So that's the current that we have currently, and the resistance was 10 times 10 to the 3 ohms divided by 1 times 10 minus 3 amperes. And this gives us a resistance of 1.4 times 10 to the 7 ohms.